In this next example, we want to determine if the series converges absolutely, converges conditionally, or diverges. We have the sum from n equals 1 to infinity of negative 1 to the n plus 1 divided by the square root of n. So we first consider the sum from n equals 1 to infinity of the absolute value of negative 1 to the n plus 1 over the square root of n. This will equal the sum from n equals 1 to infinity of 1 over the square root of n. And if you recall, this is a p-series with p equal to 1/2. So this series in particular will diverge. Now, let's look at the alternating series test to see if our series that we started with converges or diverges. We know that this is the sum from n equals 1 to infinity of negative 1 to the n plus 1 times 1 over the square root of n. So our a sub n here is equal to 1 over square root n. We know that a sub n is greater than 0. So we do indeed have an alternating series here. Looking at the alternating series test, we want to first consider the limit as n goes to infinity of a sub n. That is the limit as n goes to infinity of 1 over the square root of n. And as n goes to infinity, the square root of n goes to infinity, so we have a 1 over infinity, which tends to 0. Next, we want for a sub n plus 1 to be less than or equal to a sub n. Notice that n is less than n plus 1. And it's positive. So that implies that the square root of n is less than the square root of n plus 1. And it's again positive, which tells us that 1 over the square root of n is greater than 1 over the square root of n plus 1. Or in other words, a sub n is greater than a sub n plus 1. That's our second criterion on the alternating series test. So, by the alternating series test, the sum of n equals 1 to infinity of negative 1 to the n plus 1 over the square root of n converges. What this means, since our sum converges, but it diverges in absolute value, we have conditional convergence, or it converges conditionally.